to. So thank you for stepping in.
Yeah,
Yeah.
hope you're doing well, Bob, and thank you everyone for staying back. Obviously, this would have been marvelously and multifoldly more interesting had Bob been talking about the work he has been doing. But nonetheless, I'll try to see if I can do some justice to the work that is really a celebration of the 5 decades of the work Bob has been doing with regards to urban thunderstorms and other things that we have heard. So I'm just going to basically go over some of the slides and see the summary with regards to the manner in which his career has been evolved. And this is essentially a conversation that I'm going to do on behalf of Bob, looks like. And so the first is, of course, that he's thanking the committee and the board in particular and everyone and the students and collaborators that have gone in. And part of the discussion starts with the two conversations that he highlights. First was with uh, Jim Deardorff. Many of you might know the convective velocity W star comes from the Deardorff 1973 paper. And around that point, I think Bob had a conversation and asking Jim to talk about urban boundary layers. And his comment was to stay out of polluted urban boundary layers and walks away. Point being, people were not really interested about urban boundary layer at that point. Conversation two with John Wingard. Wingard, as you know, the Bussinger Wingard Izumi B. Bradley, the BWIB scheme. So that's Wingard. And the question about why are you studying urban boundary layers when we have still not understood the rural boundary layers? And Bob's response about let's not wait to understand everything, but go ahead into the future, so we can't wait for that. So it sort of lays a framework that people were not really ready to study the boundary layer processes in the urban area when he was clearly advancing some of our understanding on this topic. Uh, Many experts that have been listed here, some of them not listed because of lack of space, but much of what Bob's work has been with regards to is the mesoscale meteorology and air quality, which has been the initial result, and we saw some presentations related to that. And then the hard challenges associated with the issues of thunderstorms, particularly in urban areas, and the interaction with aerosols and air pollution, and the interaction between the rain and aerosol and the whole urban feedback. And the lesson one that emerges from what has been his first part of the work is to get the two things right. We need to first correctly simulate the urban impacts on temperature and the winds. So essentially, before you go into the dynamics and before you go into the air quality aspects, you really need to get the basics right, which is with the foundational aspects of the temperature and wind speed, the primary variables that start from there. You saw this in Dow's presentation about the splitting of the thunderstorms and the work that has been done over Beijing with the context of including the city and not including the city. Here it's Beijing, it could be New York, it could be any other city to go forward. But the point there that as you're trying to represent the processes with regards to the urban areas and so forth, the lesson one that he highlights is that under prediction as Bob grids are denser than observation sites, meaning that much of what we observe, the course of resolution, is often not able to capture what we are trying to get with regards to the urban feedbacks, which are much more subgrid scale in feature. Uh, the case two here he highlights is with regards to a case over the New York City ozone scenario, where you see a beautiful front moving in, and that front actually slowing winds as they come into the urban area. And as the winds slow down, that allows for the photochemistry to start building up. I think Alexander was talking about how the photochemistry works in with the NOx reduction and other things that could happen, and in that process, the slowing actually has a dynamic feedback, is also resulting into a photochemical feedback, resulting into an increase in ozone levels. And so you can see that with regards to the simulations, that when you start introducing the New York City and without New York City, the front could be stalled. The stalling of the front allows for the ozone concentrations to build up, and actually, what is a dynamical feature then starts becoming an air quality feature of that thing. There have been also some studies that went on with regards to the high speed trajectory modeling analysis with regards to how this was a very narrow band of ozone layer that came in at increased concentration, a paper that is now being published, I think, in 2022 in JAMC. So good modeling and good observation inform each other. A point that was made in the previous talk as well, that as you observe, you should model, and as you model, you should observe. And together, then you have a better understanding. Uh, Over the years, of course, Bob has been the cornerstone of the San Jose State's meteorology program and all that has been evolving. But also, what has been the cornerstone of his work has been the developments with regard to the urban meteorological boundary layer schemes. In fact, his email, which is the PBL model at hotmail.com, probably needs to be trademarked. And that has been the definition of what Bob is. And so it starts off with his early work from his PhD days with the observations of the urban boundary layer, one of the first observations to look into the dome over urban areas, and then the 2D, 3D, and the multifold evolutions of the 3D were modeling scenarios with regards to starting from the PBM to MF5 to WRF to the urban birth, and of course his co-conspirators with Meow and Hore working with much of the surf and the indigenous data going forward. Uh, in the 60s, the earlier part of the lesson that we have is that many urban weather climate impacts, our city centers, are battled between the conflicts. I mean, it could be, I was reading a book about how the job of a CEO is an exemplification of the apparent opposites. Like, you have to be uh, doing something and you have to be at the other time you'll have to be doing exactly opposite to advance your goal, etc., etc. I think in the context of what we were seeing with regards to the questions that were being raised in urban areas about what is happening with regards to urban area and the feedback on dynamic meteorological features, we had very clear things that are going on. Are winds going to be increasing because of heat island, or are winds going to be slowing because of the blocking associated with the roughness? Are wind directions going to lead to a convergence where you're actually going to have winds going into the city, or they're going to create a divergence with winds moving away from the city? Are you going to have thunderstorms which are going to be triggered over the urban areas, or are the thunderstorms going to be deflected away from the city? Or are we going to have more precipitation over the city, or are we going to have more precipitation downwind of the city or away from the city? So these were the conflicting aspects that seemed to emerge. And if this was Bob, he would have gone probably 20 times faster and ignored your 5 minutes, but I will continue on that. But so here are some examples about the urban dome that has been presented with regards to the first observation. We had this as the urban dome. Still, we don't have many measurements of this nature where we don't understand the height over which the urban heat island exists, though we have a good feel about the spatial data sets, especially because of remote sensing products that we have in place. Uh, Here's the work from the 2D urban Met model, where we show the concurrence of the roughness actually decelerating left of the storm and heat island actually accelerating the storm on the right of it. So you could have both the decrease of the speeds in some part of the city and increase of the speed with regards to the heat island occurring, and that is the apparent contradictions, but yet occurring because of the storms moving, because of the two features. So the main lesson here is that urban boundary layer impacts are four-dimensional. That means you not only have to look at it into the surface, whether it's the left or right of the storm, but also with regards to the vertical structure that you're seeing and the changes that will occur with time. So not one location, one observation at one point can tell you the whole story. You need to look at it in the whole 4D. Looking forward, you see the typical Bob Constant plots where half the images are marked with his own handwriting, but tremendous amount of information with regards to the convergence zone and the fronts that you can start seeing there with regards to how the drags the roughness created a front and how the blocking and other features can go in. I'll leave your imagination to these figures to come up with your own understanding, but the point here being that the roughness and the urban feedbacks are going to have a multi-complex feedbacks, not just at the local, but cascading into the manner in which the funds are going to move. And here's an example of that where you're trying to see that when you're using two different boundary conditions, one from an ETA model, which used to be the precursor to NCEP world, and then the other one is with regards to the NCEP blue model. So you have basically two different boundary conditions for the same event, one in pink and one in blue, and you start seeing a very different forecast. The general shape of the front is pretty well captured, but if you look at the San Francisco Bay Area, one could be a mixed forecast and other could be a good forecast, even though the physics is right. So the lesson here is to check for the accuracy of the large scale initial conditions before you run your mesoscale forecast model. So you know that not often that it's going to be a model's fault. It's probably the boundary conditions you're providing, the domain size that you have, which could be causing the issues and not really the boundary layer physics or other factors. The out of the observation that went on that I think he and Jorge had been working in the California region. I believe this was a work that Jorge had been doing when he was even at Riverside for a very brief evening, I think, of his career. Where they're trying to look at the changes in the warming and cooling rates with regards to where we are spatially located, whether in the valley or into the higher altitudes. And then you could see that the presence of a coastal urban feedback with regards to the sea breeze would actually lead to a cooling, and which is a reversal of what you would actually have with regards to the global warming signature, quote unquote, in terms of the larger region. Point being that the urban sea breeze interactions would actually create very consistent climatological features onto your region's climate going forward, and that needs to be done. So when you look at the other improvements that have been done by the work, we heard some of them with regards to the cooling towers and so forth that have gone with regards to the work. The introduction of the Martinez scheme with regards to the BEM models that we use. Bob has been, of course, quite instrumental in working and training Alberto and the creation of the initial modular modules, which were introduced in the TBM model, and then went on to become part of many simulations that have gone over the years in the world, both with ODAP, both with the BEM model scenarios going forward. So going forward, Bob is, as you know, a very young guy, and he's very interested in looking over the next 25 years of what needs to be done in this topic. But one of the few things that are of interest relate to the issue of the role of buildings and the bifurcation and the interaction of the morphology versus air quality, particularly with regards to the aerosol interaction. That still remains one of the active questions that is existing. We have the issue of the rural soil moisture playing a role in terms of the feedback you would have on the urban area. There is a talk by Alexandra briefly about that. The California coastal cooling work and the impact that it will have on the urban processes and the information that might be on more recent decades. The work that was published was from prior decades, so updating that information. Work with EnviMed at a very high scale with regards to the CFD-TK models to mobile phone data that we just heard about, and how that would be used in terms of the model versus almost like citizen science input for analysis, and then to refine the work model to incorporate Alexander's paper and to look into the issue of the PBL height formulation with different schemes, TKE formulations with regards to better turbulence parameterizations, and then Serge's work with regards to the boundary layer formulations, which goes from the spectral world into the more of the turbulence world going forward. So, with that, I of course take the opportunity to thank Bob for all the work he has inspired over the years, what I have been doing, and of course for all his contributions with regards to what he has done to the whole urban boundary layer scheme. With that, I take the opportunity to celebrate his legacy and wish him the very best for the next 50 years as we celebrate what he'll be doing. Thank you again, Bob. And if you have any final comments, the floor is always yours.
Fantastic session. And if you remember, in Yokohama, I received the Landsberg Award, but I had cancer surgery. And now I had cancer surgery. No more awards for my CUC, please. But
Well,
everybody did a fantastic job. Really was wonderful. And all the people I worked with, all the students I work with just are fantastic, and they had wonderful ideas, and I helped them polish their ideas. That's all I did. And by the way, Dan, if I was a pioneer in precipitation, you were number two. You always picked up and you went beyond what I had done, and you had a number of landmark makers in precipitation.
Thank you, Bob.
Thank you.
Look forward to publishing some more with you. Thank you again. And with that, I will let the chair close the session and all the efforts. But thank you again.
Well, thank you everybody for coming and learning about Bob's legacy. Thank you to